Well, hello, year 11. I'll close that behind me, so that's a bit easier, isn't it? Curtain behind there. Sorry about that. Yes, welcome. I thought I'd best describe our last area of study because we've got one last S to achieve for Unit 1, and we're now going to be re-crammed for time when we get back after lockdown. So, I'm going to get you to do some work on this during lockdown. I know we're meant to be doing revision, and I'm going to make sure you have plenty of time for revision as well. But one class has 3 periods for data collection. The other has 2 when we get back to school after exams. I think might be less. Let's hope it's not less. So I really need for you to think through this process. Now, I've created this as a style worksheet, so it's a bit easier to follow. A little bit of introduction there. This is the dot points from the state design. This is the stuff you're meant to be trying to make use of. So the idea, this is a chance for you to show you know how to plan, conduct, and report on an investigation. It's an important skill of science. And you get to choose one aspect of the unit study. Our intent was to do our field work in the reserve. And therefore, we're really looking at, the stuff we've been studying. Animal regulation, adaptations, organising biodiversity, so classification and why is biodiversity important, and the idea of relationships between living things and the energy and matter flowing through. So I sort of get up some examples here of, stressing, keep it simple. Let's just keep a nice, short, sharp activity so we can get it finished and you guys get your S, and next semester we can start fresh with Unit 2. So some thoughts. Animal adaptations. We've got quite a few captive animals. We've got a range of wallabies, tamars, rednecks, brushtails, swampies, little rufous bettongs, kangas, and the emus in there that are fairly easy to watch and consider. Lots of plants to look at as well, of course. So what about animals and plants? How they regulate to survive the change? Obviously it's a cold, wet time now, having been through a dry, hot time over the summer. How these animals and plants survive that. You might want to look at classification of living things. So you look at classifying animals and plants in the reserve. Could be a little guide to the indigenous plants or indigenous food plants, food medicine fibre plants for our indigenous peoples, or pest plants. But some little activity where you actually do some work to identify and classify some of the living things in there. You could look at how plants and animals are distributed through a small environment, but we do see quite a bit of change related to the abiotic factors, so you might have a look at that. Or you could think about that bigger question of, okay, I've got pest plants and animals I wish to control, and I'm controlling them because of their disruption to my local ecosystem, because they disrupt energy and matter flow. So there's a bigger question there, I suppose. So what do you wish to study? Short, sharp statement form in there. Background's the most important part of any study. If you get your background sorted and worked out, you know what you're trying to achieve, so you write a good method, collect the data you need, and then you can analyse and write a really good conclusion to what you've discovered. So this background part's critical. And it also, from this point of view, it relates back into the course you've been studying. So it's a bit of revision too in some ways, so it's not a bad thing. Place to upload that. So you might have Word documents, you might have URLs, all that sort of stuff you find that you want to use to show you've done some background research. Variables are a bit tricky. It really depend entirely on what you end up doing. They're a bit harder in field studies, but you might have an independent variable, you might have a dependent variable. You certainly will have some variables which you control, and so using Braun-Blanquet on quadrants and transects are an attempt to control the manner in which data is collected. So you might have a control for the experiment. Again, difficult in field studies, so it really depends on what you decide to study. So if it doesn't suit, don't worry about it. If it doesn't make any sense to write one, don't write one. But if it does, try and make sense of your control. Then you've got to write yourself a hypothesis, and I've sort of pinched this little graphic here from the junior one where they try and explain to the junior kids how to do this. So one good way of writing hypothesis is the old if-then statement. So if we change the independent variable, then the dependent variable will change like this. So if I increase the amount of light, then the growth of plants will also increase. That's sort of that statement. That's very simple. We're doing something more complex, but just to help you get your head around writing a good hypothesis. And then, of course, you've got your method. You're your 11 science students. You've done a lot of science. You should be able to give me a really good, detailed, numbered list. Your method should be repeatable. Someone else should be able to pick up your report and do precisely what you did and get precisely the same result. So a good method meets that criteria. And you'll write one if you've done a good background to your hypothesis. So if you really know what you're trying to achieve, you will know what data you need to collect, and therefore you know how to collect it. And that will lead you to a list of stuff you need. Clearly I need to know that in case I need to get stuff for you, right, for your data collection. And then of course you need to think about safety. We normally use risk assess for this, but for this, considering our time constraints, I'll let you just list stuff for me here, and I'll clear it with Mrs. Perry. I might have to do the risk assessments for you, but that's okay. Make this thing doable. While you're doing exams, I can write risk assessments. And then, of course, we'll conduct it. So the conducting we'll do after exams. And obviously, exams are going to be delayed with our lockdown. So hopefully, we'll get 2 or 3 periods to actually collect some data. We'll have to work really fast in the field. That's a couple of hours, basically, which is crazy. Now, obviously, you make lots of tables and measurements and things. It won't always relate to a graph because, again, you're doing field studies. Graphs aren't always as useful in this situation. So that part we'll try and get done last week of term. And then this last bit, unfortunately, can have to be homework for holidays. I was hoping to give you a bit of a break, but again, it's not going to be a huge amount of work. It's just by then, it's trying to make sense of what your data tells you. So it could be a couple of hours of just writing up. Okay, this is what my data tells me. This is what I've learned from it. And this, evaluation. Use your scientific concepts that you've got in your background to explain what you've identified. What new questions you have. Do you actually has this generated new questions? Because that's often the case of the study. You end up with not enough data to explain everything you've seen, and you've got some new questions for the future. And of course, some sort of conclusion. Did your data support or refute your hypothesis? Why? You should always include your references and acknowledge those who have helped. And then there's a rubric there to explain what goes on. So during our sessions in lockdown this week, before exams start, I'm going to use a little bit of time to get the background, the hypothesis, the aim, the materials, that sort of stuff done, the method done. So I need you to have that ready so I can make sure that you've got the materials you need for those couple of classes we're going to have. It's a bit of a mess, isn't it? But anyway, we're all safe. We're all healthy. I hope so. And I'll see you on Zoom.